Okay, we're continuing with more example problems where we're simplifying rational expressions or expressions that involve rational expression terms. So in the previous video, we simplified just single term rational expressions as well as the terms where we were multiplying or dividing different rational expressions. So here we're going to do problems where we add or subtract rational expressions. And so the method here is you just want to create a common denominator. You want to multiply each rational expression by 1 in the form of whatever expression you need to create a common denominator. Then you combine everything, and what you're going to be left with is a single rational expression, and then you just simplify that like we did in the previous video. Like you simplify any rational expression in general where you factor the numerator and denominator and simplify. So now, but still, though, even here, it's interesting to think about how, we have to, in general, start by, so this is what we're given to start with. This is like, it's kind of like this is your algebraic model to where you modeled something in real life. Okay, this is it. These are all of your inputs, from the factors coming from something. Well, we can see that m can't be minus 3, for sure. So it doesn't matter what we simplify and get in the end. Whatever we get, m can't be equal to minus 3, even in that. Right? We're going to just clean this up, get it to a nice simplified form to where we can take in any input variable. Instead of putting it through all this, we can put it into some simpler form. But still, the model, the original model is this here. And m can't be minus 3 because you can't divide by 0. So, okay. Well, here we already have a common denominator, so we can just go ahead and combine these. All right, now we're just left with a rational expression, like normal. So what do we do? Well, we factor. So factor the numerator and denominator. So, okay, 3. Okay, so we're left with just m plus 3. Well, we can input minus 3 in here. So what's wrong with minus 3? Because this is just no, m cannot be minus 3 here. This is just a simplified form. It's like we're writing a computer program or something, and if the person that's inputting something into our computer program, like an ATM machine or something, inputs minus 3, or inputs, not minus 3, inputs anything. Well, all we have to do is just take whatever the input is and add it to 3. Boom, there's the answer. We've simplified it. Just add it to 3. Really simple. However, we have to put a caveat in there that says, okay, yeah, no matter what the input is, just add it to 3, and that's going to be the output. But if they input minus 3, then say invalid input. Even though, yeah, minus 3 plus 3 is valid, no, but for the original function, it's not. Okay, so now here we need to create a common denominator. So let's see. As far as the coefficients, so 15, okay, 30 is not divisible by 9. 45 is divisible by 9. So, okay, we're going to multiply this by 5 over 5 as well as c, so 5c squared over 5c squared. 1 in the form of 5c squared over 5c squared. So we haven't changed anything about the expression. We just multiply this by 1. Here, we're going to multiply this by just 3 over 3. So we haven't changed anything, right? We just multiplied both terms by 1. So, okay, we're left with, let's see, 10c squared over 45c cubed. And then here we're left with 21 over 45c cubed. So now we can combine these. We get 10c squared plus 21 over 45c cubed. Okay, now can we simplify this anymore? I don't think so. No, that's it. Okay. Now, but we see that c can't be 0, but in this case it works out to where we can see c can't be 0 anyway. So in this case there's no confusion. Like we couldn't even input c is equal to 0 into this either. Okay, let's see. Here we want to multiply by, to create the common denominator, we want to multiply by y over y. And then here we want to multiply by 2x over 2x. And that should be good. So 9y over 2x squared y to the fifth. And then 2x squared y to the fifth. And then we've got 22x. There we go. So 9y minus 22x over 2x squared y to the fifth. And there you go. And then x can't be 0 and y can't be 0. But again, here it doesn't matter. We could have seen that directly from this. Okay, let's see. So here the common denominator is going to be x times x plus 3. So we want to multiply this by x plus 3 over x plus 3, and this by x over x. But again, we haven't changed anything about the expression. We just multiplied this term by 1 and this term by 1. So we have 2x over x times x plus 3, and then we've got, so x, and then 7 times x plus 3. So now we can combine these, and then x. Okay. So now let's go ahead and expand this out in the numerator here. So minus 7x minus 21. So, okay, 2x minus 7x is minus 5x. And we could just, let's go ahead and do this. Yeah, so, okay, now x can't be minus 3 and x can't be 0, but even here, that's going to be the case. Even with this term, that's going to be the case as well. So, yeah. Okay, let's see. So, yeah, when you're trying to find a common denominator with polynomials, it makes it easier if you factor them and you can see the factors. So, let's do this. Let's take out an x here, and then here, let's factor this difference of 2 squares. Now we can see what we need to create the common denominator. So this, we need an x over x to multiply by x over x. Here we need to multiply by x minus y over x minus y. And then we'll get, so x minus y over x times x minus y times x plus y. And then here we'll get x times x minus y times x plus y, like that. Okay, so we've got x minus y minus 2x over x times x minus y times x plus y. So x minus 2x is minus x. Okay, now we can take out a minus here and we get x plus y. Okay, now we can see these cancel and we're left with minus 1 over x times x minus y. So, okay, so x can't be equal to 0, x can't be equal to y, right? But then there's also like the x plus y can't be equal to 0, so x can't be equal to minus y, right? If we look here, x can't be equal to 0, x can't be equal to minus y, and x can't be equal to y. So we've got all three of those. The x is equal, can't be equal to minus y is not shown in this expression. Okay, so let's see. The common denominator is going to be y squared times y plus 1. So we want to multiply this by y times y plus 1 over y times y plus 1. We want to multiply this times y squared over y squared. We want to multiply this by y plus 1 over y plus 1. So we're going to get 5y times y plus 1 over y squared times y plus 1. We're going to get, and then 2y squared over y squared times y plus 1. And then here we'll get 6. Okay. So we've got then plus 2y squared minus 6. Okay. There we go. So now we've got, let's see, 5y squared plus 5y plus 2y squared, and then minus 6y minus 6 over, and then we'll just leave this factored for now. Okay, now let's see. 5y squared plus 2y squared is 7y squared. 5y minus 6y is minus y. Okay. Okay, now let's see. Can we factor this? Yeah, we should be able to. So 7 times 6 is 42. So 7 times 6 is minus 42. So we have minus 7 and positive 6. So we can do 7y squared, and then we would do minus 7y plus 6y minus 6. And we haven't changed anything. So we can factor out a 7y, and we get y minus 1. Factor out a 6, we get y minus 1. So 7y plus 6 times y minus 1. Okay, so now we can't cancel anything out here, so that's it. Now, yeah, as far as the restrictions, you just, okay, so y can't be 0, y can't be negative 1, and that would be it. That's the same thing here. Okay, here we see that, so we can do, so 3w over w minus 4. If we factor out a minus 1 down here, we can write it like this. We can say w minus 4, right? Because let me make this clear. So we could do this. We have plus and then minus w minus 4. Well, we can write that like this. So plus, and then we could just put the minus. But we could just put that minus out front. Like that. Right? So we've got 3w, and then we have to distribute this minus. So minus 2w minus 4. Okay, so 3w minus 2w is w is 1, but w can't equal 4. You put that right next to the 1. It's weird. Okay, let's see. Let's factor these denominators. So x, we'll do 5, 1. Okay. Let's see. X, 5, 2. Okay, so now to create the common denominator, we can clearly see with these factors what we need to do. So here we need an x plus 2 over x plus 2. And here we need an multiply by an x plus 1 over x plus 1. And so what we'll get is, we'll get 4 times x plus 2 over x plus 2 times x plus 5 times x plus 1. And then here we'll have x plus 2, x plus 5, x plus 1, and then 3 times x plus 1. Okay, so we'll have, let's see, it's going to be 4x plus 8, and then minus 3 times x plus 1, and then x plus 2, x plus 5, x plus 1. Okay, so we've got, let's see, 4x plus 8 minus 3x minus 3, which is going to be x plus 5. So, okay. Then okay, so let's do x plus 1, x plus 2. There we go. But now x, coming back to the original equation here, x can't be equal to minus 5, x can't be equal to minus 1, x can't be equal to minus 2, even though minus 5 would work in this final expression. Still. Okay.